Welcome, class. Today we're going to be starting Chapter 6, and sorry I'm not in your class with you. They actually have me working on some curriculum. So you're going to be starting Chapter 6 without me, but that's okay because this first lesson isn't too hard and you've been exposed to it before in middle school. So just to get started, hopefully you have your note packet out and ready. Chapter 6 is all about exponents. There are 6 lessons in the chapter. The last 2 lessons, 6.5 and 6.6, really are kind of the same lesson. And again, I know we've said this before, but in the second trimester, we'll probably have to do these 2 lessons together because we won't have the time. But since first try, we've got a little bit extra time here, we're going to go ahead and separate these 2 and kind of give you a little bit of time to absorb them and really truly understand them. This one right here is really, really big for Algebra 1B. So I know you're going to have geometry in between, and your teachers know that, but they'll review this. So if you don't understand 6.6, Algebra 1B is going to be very difficult. So that's why I like spending 2 days if we can, okay? So since there's 6 lessons, probably about halfway, so after 6.3, we'll take our quiz, and then we'll do the other ones, which is going to basically put your Chapter 6 test the day before Thanksgiving break, which will be Tuesday, the 22nd, okay? So Chapter 6 is going to take us all of next week, and then it'll have that Monday we'll review, and then Tuesday we'll take your test, and then you guys are off for Thanksgiving, and then when you come back we'll take exams, okay? So I guess basically also this is your deadline for any Chapter 5 retakes. Okay, and I know I'm not here today, but if you I heard to put retaxes, retakes. There we go. That's why I teach math and not English. So if you want to do a retake, make sure you schedule it with me before that Tuesday. Okay. All right. So before we jump into Chapter 6, I have a little activity that I have a PowerPoint, but normally if I was there, I'd show you the PowerPoint. But since I'm not there, this would be the easiest way. So I want to have you test your memory here just a second, okay? So no calculators, no pencils, no nothing. So put everything down. I'm going to show you a number, and I want to see who can remember the most, okay? So you ready? Okay, write down as much as you can. So grab your pencil or pen and write down as much of that number as you can. And what I'd like the substitute to do is go ahead and pause the video right here, and let's see who is the largest. So if you look on the paper that I gave you, there's the numbers written down. So you'll see the number again, okay? So see who's the largest, and you can give them a piece of candy. All right, hopefully you paused the video and you went around and saw who's the largest. Now, this is a very big number, okay? And I don't think many of us are going to remember a ton of it. And so today's lesson is about really large and really small numbers. So a better way to remember this number would have been to put it in scientific notation. So notice I only really had to remember 3 digits or even maybe 2 digits, but notice my power, my exponent. This chapter is all about exponents, whether that's positive exponents, negative exponents, it's all about exponents. The other thing this chapter does is instead of giving you all numerical, they're going to also give you stuff like this. Maybe not 2.8, so maybe like 28x to the 5th times 5x to the 9, y to the negative 3. So in this chapter, not only are you going to be dealing with numbers, these are called coefficients, along with exponents, but you're going to have what we call bases. So there's a lot going on in this chapter, okay? Lots of little rules, not a ton of story problems, so some of you might be happy about that because I know you hate story problems. So not a lot of story problems, but lots and lots of rules to remember. Okay, so hopefully you got the winner there. Now, one of the things they say is that our memory, and I just got this offline, but our memory, you know, we have a hard time remembering things. And they say like short-term memory, you can only remember something for 20 to 30 seconds before it's gone. They also say that a lot of times we can't really remember more than between 5 to 9 items, and they say some of us are even closer to only being able to remember 4. That's why I think about phone numbers. I know we don't really know phone numbers anymore because we just put them into our phones, but think about when somebody tells you a phone number or you hear a phone number on the radio and then you try to call in. If you keep saying that phone number to yourself and somebody interrupts you, can you remember the phone number? So our short-term memory is not great, okay? But this is, again, something that I just wanted you kind of to give you a little introduction, that if somebody gives you a large number like this that has 16 numbers in it, how can you remember it but not have to remember all 16 numbers, okay? So today's lesson is all about scientific notation. So if you grab your notes or if you got them in front of you here, again, scientific notation, I know you've done it before, is when we either have really large or really small numbers, okay? So when we're dealing with scientific notation, there's going to be 2 things that are going to occur. We're either going to have a positive number, a positive integer, which let's just say take the number like 5,400. I know that's not super big, but I don't want to get too crazy here. So 5,400. If we were going to write this in scientific notation, we would go 5.4, so you move the decimal between the 2 numbers, and then you count how many places you moved it over. So we moved it 1, 2, 3. So this would be times 10 to the 3. Now, your calculator for 5,400, your calculator, 5,400 is not going to bother this calculator, okay? But let's say, I don't know if you can see that or not, there you go a little bit. Let's say we went crazy and we went 54, and instead of 2 zeros, let's just say I hold down a whole bunch of zeros, okay? So I don't know where I'm at, million, trillion, billion. Watch if I hit enter. This is how the calculator does scientific notation, and I'm not the one who made the calculator, so I don't know why they used E. I'm assuming it's for exponent, but again, I'm not the maker of the calculator. So when you see this in your calculator, instead of doing times 10 to the third, your calculator will do 5.4 E to the third, okay? The calculator uses E instead of 10. It doesn't really matter to me. If you're on a test, this is how it would be written, but if you're working out problems, you might see it this way. Now, if you want your calculator to be in scientific notation all the time, so even for 5,400, you're like, what is that? I don't remember. Go to the mode key, and it's the very first option if you move over and highlight the words SCI for scientific, and then go out of there. Now hit enter again. Notice it'll kick it into scientific notation. I mean, it'll even kick like the number 5. It'll put that in scientific notation if you change the mode. Now, if you don't change the mode and you stay on the normal part of your calculator, the number has to be fairly large for it to kick to scientific. So notice even right there, that's what 54 million. 54 million doesn't bother the graphing calculator. But what if we went 54 billion? Then it would affect it. So I just want you to be aware of what does this E stand for in the calculator. You may or may not see it. Now, small numbers. So small numbers are going to be your negative exponents. So positives are your big and negative is your small. So let's just say we took a small number, like how about 0.0054, okay? That's a fairly small number. What we're going to do is move this decimal point between these two. So this would still be 5.4 times 10 to the, but because it's small, we do negative. And then we still just count 1, 2, 3 places. So it's to the negative 3. So in the calculator, this would be 5.4 e to the negative 3, okay? Again, just wanted to show you this. Now, down here on the first section, they want you to write this as a power of 10. So really what they're saying to you is it's 1 times 10 to the what? What power do we have to raise this to? So we literally just count 1, 2, 3, 4. So if we put the decimal point right here, that means I moved it 4 places. Now you don't have to put the 1 out front. It's considered understood, so you don't have to put that. So if we were doing 100, we're moving the place 1, 2. So this would be just 10 squared. You don't have to put the 1 times out front. Now when you're doing decimals, you got to be careful here. So when you're doing this decimal, you have to move it to this position. So it's 1, 2, 3 spots. So this would be 10 to the negative 3. So if you count the zeros, that will help. The only thing that gets tricky sometimes is if they don't put this first 0. So let's say they would have done this to you. Like that. So if it's written like this, a lot of kids will say, well, I see 4 zeros, so it should be 10 to the negative 4. But that's not correct, because if you move it 1, 2, 3, 4, it only puts it right there. And you need it one more spot over. So this is to the negative 5. So in a way, you want the 0 out front. If you have the 0 out front, then you just count 1, 2, 3, 4, 5 zeros, and that's my exponent. So 4, take a guess. You're just moving it one spot. So 1 spot or 1 0. Then in the next section, they're asking you to put it into scientific notation. So this one, notice there's 4 actual numbers here. So what we do is we always place it between. So the number to the left of the decimal point cannot be higher than a 9. So you cannot have this. Like let's say we'll use this one. I cannot go 45.78. That won't work. You can only have one position to the left. So it'd be 4.578 times 10, and then we moved it over 1, 2, 3, 4 spots. So this would be 10 to the 4th. And because it's a big number, we do it positive. Now again, if you really weren't sure, let's say, I know we have a no calculator portion, but if you were on the regular part of the test and you really didn't know, notice that's not going to kick it to scientific. But if I go to mode and switch my calculator to scientific mode, notice now it'll place it in scientific for you. So the calculator can be helpful. I think you can do it faster in your head, and I know you guys are smart enough. It's just, I wanted to show you that. So why don't you pause it here for a second, and actually, why don't you try 6 through 10? Try all of them. So 6 through 8, you're going to put it in scientific notation, and then 9 and 10, take it out of scientific notation. So please go ahead and pause it here. All right, hopefully you've paused it. So the correct answer would be 5.47 times 10 to the negative 1, because I only had to move it over one spot. And because it's small, notice it's negative. Number 7, I need to put it right here between the 3 and the 1, so 3.12 times 10 to the 11th. So 3, 6, 9, 10, 11. So it'd be the 11th. And then this one, I need to put it between the 1 and the 9 and 5. And then again, because it's a decimal, I'm going to make it a negative. And if I count 1, 2, 3, I move it 3 spots. Then number 9, they're giving it to you in scientific and they want you to take it out. Now notice this is negative, which means you're going to make it even smaller. So what you have to do is you have to take this decimal point and move it to the left 2 more spots. So see how I moved it 1 spot? I need another 0. So this is like the original, and if I move it 1, I need another 0. So it would look like this. Now, if you want to put the extra one out front, you can. It does kind of help, but it's not a big deal. So if I were to move it back, 1, 2, notice that's how you got the exponent. So this one, I got to move it 5. This is going to make it huge. So I've got my regular number. So if I move it 1, I need 4 more. So I got to add 4 zeros. And then please put your commas in. Now, since we're talking about this, and you got a little bit of extra space right here, okay, I want to ask you another question. So my question is to you, what is the largest U.S. currency that's ever been printed? What is the largest paper money that we have ever had in the United States? So take some, questions here, or people throw out some answers. So the correct answer is a $100,000 bill, and President Wilson is on it. So $100,000 bill is actually the largest one that they have ever printed. Now, I just quick looked up some information because I thought it was just kind of interesting. Notice 1, 2, 5s, 10s, 20s, 50s, and 100s are the only one that they still actually produce. But this $100,000 bill is the largest one, but notice it stopped being printed in 1935, which I think is interesting because who in 1935 had that kind of money that you would need to carry this kind of a bill around? I mean, could you imagine going to the grocery store? Yeah, I'll take a couple bags of chips and give me change. So I just think it's kind of interesting the year, because back then even $1 was worth quite a bit different. So down here I just found this information. It says production of the 500, 1,000, 5,000, and 10,000 denominations stopped being printed after World War II. So online it said that they still do exist, but you have to go to, I think, the Treasurer Department if you want one of these. So if you went to like Washington, D.C., and you had enough money, they could give you one of these bills. So I would love for you to come back someday and show me one of these bills if you have enough money. So kind of just in talking about money, the question that I gave you at the very beginning, this number that you had to remember, does anybody know like what this position actually is? Because think about, you've got ones, tens, hundreds, thousands, then you're going to go into millions, then you're going to go to billions. So can you guess? All right, so this would be a quadrillion. So again, we've got hundreds, thousands, millions, billions, trillions, quadrillion. So if I had a quadrillion, I'd be on a beach somewhere, okay? But this is actually what the rest of them would be after a quadrillion. Then you get to a quintillion, a sextillion, a septillion, because it's 7, octillion, nonillion, and a decillion. So just kind of something interesting. Then you've got a little bit more space there on that paper. I want to ask you just a couple more questions here regarding that 100,000. So pennies. If you were dealing with pennies, how many pennies would it take to get to $100,000? So go ahead and see if you can jot that down. Maybe you need to pause the video for a second. Jot that down on your notes, just off the corner or something. How many pennies do you think it would take? All right, did you get an answer? Well, think about, for every dollar, it takes 100 pennies, right? So you'd have to take this times 100. So think about how many zeros you have here. You've got, what, 5 zeros here, and you'd have 2 more zeros here. So it's really 10 to the 7th. So it would take 10 million pennies to get to $100,000. So if you got a piggy bank at home, how big is your piggy bank? All right, how about you try this one? How many dimes would it take? How many $10 bills? And how many $100 bills? So go ahead and pause it here. And what I'd like you to do is pause it for a couple minutes, have them try it individually, then have them talk with their neighbor. So have them compare with their neighbor. So maybe take about 2 minutes here. All right. Hopefully you have paused it and you've tried it. So in dimes, this would have to be times 10. So notice this one was times 100, which was 2 zeros, and this only has 1 0. So this would actually be 10 to the 6, which is the same thing as 1 million. So you'd have to have 1 million dimes. How about $10 bills? Well, think about, if you have 100,000, we wouldn't want to multiply anymore. We would want to divide. So we'd have to take 100,000 divided by 10, and that would give us 10,000, because basically it would just cancel off a 0. So it'd be 10,000, which would be the same thing as 10 to the 4th. So again, if you count 1, 2, 3, 4, you'd have 4 zeros. All right, so then this one, if you got number 3 wrong, maybe rethink this one real quick. Instead of dividing by 10, I would divide by 100. And notice I get to cross off 2 zeros, so that would give me 1,000, which is the same thing as 10 to the 3rd. So basically what I just really wanted you to do or see with this activity is just, when you have large numbers like this with zeros, it's just counting the zeros and then putting it in your exponent. So this whole chapter deals with exponents. Now, we won't always have the base, this is called the base, numerical. Many of your lessons, if you just look ahead in your note packet, your base is a variable. So you'll have x to the 7th maybe times x squared y cubed plus 9x to the negative 3y to the 5th. See how I have exponents and I have coefficients, but my variables are bases, or I mean, my bases are variables. I said that backwards, okay? So just something to think about. All right, go back to your notes. We have just the back page left, which notice there's not a lot back here. They're just trying to give you some examples of where large numbers are used, and honestly, it's really in science class. So Saturn has a diameter of about 1.2 times 10 to the 5th kilometers. Its distance from the sun is about this. So they're not really asking us to do anything with it. They're just saying, okay, take Saturn's diameter, which is right here, diameter, and write it in standard. So they want you to take it out of scientific. So we just have to take this decimal point and move it 5 places to the right. So there's 1 place. Now I have to add 4 zeros and then put my comma in just so it's easier to kind of quick read the number. Then it says, write Saturn's distance from the sun in scientific notation. So they want you to take this and put it in scientific notation. So remember, we put it between, we can only have 1 digit to the left. So 1.427. Now this part right here could have a lot of numbers. Usually you just put a couple, but it could have a lot. And then times 10, and now if you count, 3, 6, 9. I like that one because they're all separated by commas. So the last one, they're just trying to give you a story problem. When we get through chapter or lesson 2 and 3, this one I'll kind of show you another technique to it. But for right now, we'll probably just use our calculator. It says the island of the Bahamas has an approximate area of this. The area of Texas is about this many times as great. So Texas is that much bigger than the Bahamas. What is the approximate area of Texas? So basically, here's Texas. Hope you didn't think I was going to try to draw Texas because that's not my strong suit there. So there's the Texas is this many times the Bahamas. Now, there is one technique we could use if you know this. You can multiply the numbers together. So if we go 2.3 times 2.9, it's 6.67. And then if we add these, because see how they have the same base, we can add the exponent together. So 2 plus 3 is 5. That would get us our answer. But if you don't know that, because that technically doesn't come up for another lesson or two, just type it in your calculator. So I'll show you here. So 2.3 times 10 squared, and then close off your parentheses, times 2.9 times 10. Now remember, the third, you can either go under the math key along the left, and there's a 3 under there, or you can just use this caret key over to the side. So raised to the third. Whoops, I want to get out of that. Nope, sorry. Why won't it let me go down? There we go. To the third. And then hit enter. And notice it does not give it into you in scientific, but that's no big deal. 66,730. Notice if I move my commas. So think about the same thing. 1, 2, 3, 4, 5. Notice the place would be right there. So you can give me whichever answer you want. You're not going to see a whole lot of story problems in this chapter, or in this lesson, or really in this chapter. There's a couple that'll come up later when they talk about this a little bit more, but for today this would be fine. So hopefully scientific notation wasn't too hard and you liked some of those the money questions. I always think it's fun to talk about money. So if there's no more questions, then you may go ahead and get your assignment, and I will see you guys tomorrow.